Hello, everyone. Welcome to Seminar 7 of the Functional Food Center Standardized Program, entitled An Example of Functional Food for Mental Health and Chronic Conditions, Parkinson's Disease. Today, we will be learning about how functional food with bioactive compounds can be used to manage chronic disease and mental health condition. In particular, we will be learning about the role of prebiotics, probiotics, and the bioactive compounds play in managing Parkinson's disease. Hunter Kanya, a current employee at Functional Food Center, will be making this presentation. And this presentation is based on volume 8, our textbook, and chapter which we wrote together, entitled the Microbiota-Gut-Brain axis and Parkinson's disease. That actually, yes, as I mentioned, he and I wrote this chapter, and it was published last year. Before we begin, I would like also remind you that our seminars are free, but those who would like to become certified functional food scientists or functional food professional, so they should make a payment for the course to be able to get access to all course materials and exams and be eligible for certification. So now I will turn this over to Stella, who will go over the schedule. Stella, please continue from here.
Okay, yeah, so hi everyone. The schedule is in the chat. So we'll have around 25 to 30 minutes for the presentation, then 5 minutes for a Q&A, and then I'll launch the poll as usual for you to try out those questions for our standardized program. And then at the end, we'll go over quiz question answers. Yes, so I'll turn this over to Hunter whenever you're ready.
Okay, great. All right, thank you, Stella and Dr. Martirosyan. So let's get going on the seminar. So as mentioned, my name is Hunter Kanya, and the seminar today is how the microbiota-gut-brain axis could play a key role in the onset, prevention, and management of Parkinson's disease and its symptoms, and specifically how the use of some potential functional foods and bioactive compounds like probiotics and prebiotics can help restore the system. So a little overview of today's seminar. I will discuss what Parkinson's disease is, some of the symptoms, the diagnosis, and etiology. I'll discuss what the human microbiome is. We'll define the microbiota-gut-brain axis and its connection with Parkinson's disease. So we'll discuss, in particular, a protein known as alpha-synuclein. Next, we'll discuss some potential functional foods like probiotics and prebiotics, and what their benefits are, some of their mechanisms and studies that we've seen. And then I'll have a brief conclusion. Okay, so what is Parkinson's disease? So Parkinson's disease is a progressive neurodegenerative disorder with no known cure. Two of the hallmark biomarkers are a loss of dopaminergic neurons in the substantia nigra, as well as the formation of Lewy bodies in different regions of the brain. Parkinson's disease has two major classes of symptoms, motor and non-motor. The motor symptoms include tremors and rigidity of the limbs, slow movement known as bradykinesia, as well as impaired balance and coordination. While the non-motor symptoms can include fatigue, olfactory dysfunction, sleep disturbances, mood and behavior disorders, memory difficulties, and gastrointestinal disorders. These GI disorders usually occur in about 80% of those with Parkinson's disease. So it's a definite area of research to look into. Continuing, there are some treatments available for Parkinson's disease. Most of them address the motor symptoms only, such as levodopa or L-dopa and deep brain stimulation. The image here to your right shows some of those motor symptoms. The current etiology is unknown, and non-genetic cases are difficult to diagnose. It's important to remember that aging is the greatest risk factor in Parkinson's disease. So while these other factors are important, aging is still considered the greatest risk factor. Usually diagnosis occurs in later stages, around 40 to 60% neuronal loss of dopamine. Usually non-motor symptoms precede the diagnosis, sometimes as far as 10 years in advance. And then current research into the etiology is focusing on how the gut microbiome can play a role. So what is the human microbiome? We know that humans are host to a world of microorganisms that live in and on our bodies. In the gastrointestinal tract, we call it the gut microbiome. This image here to the right shows the basic distribution of bacteria throughout the gastrointestinal tract. The largest amounts of bacteria are found in the colon or the large intestine, with precedingly fewer amounts found in the small intestine and stomach. So it was previously thought that the number of bacteria cells outnumber human cells by a factor of 10 to 1, but recent research is showing that the ratio is actually closer as 1 to 1. This doesn't negate the importance of bacteria in the human body, and we know still that the gut microbiome facilitates many physiological functions and is associated with numerous different chronic diseases. And we know that the gut microbiota feed on non-digestible food products, mainly prebiotics, which we'll discuss later on in the seminar. Okay, so we know that there are alterations of the gut microbiome in many different chronic diseases, and research has demonstrated this reduced diversity. For Parkinson's disease in particular, we have some consistencies and inconsistencies with specific phyla, genera, and species of microbes. A review of 24 different studies examined the composition of the gut microbiome for those with Parkinson's disease compared to healthy controls. And it did confirm that there is an existence of an altered gut microbiome composition in those with Parkinson's disease. One of the most consistent alterations that was found was with a specific bacteria called Akkermansia muciniphila. This microbe is important to note because in certain different metabolic disorders, Akkermansia muciniphila is actually a decreased amount, where in Parkinson's disease, it's increased. I'll show you in this table here, these are the results of that review. Highlighted 3 specific genera. So as I mentioned, the Akkermansia and muciniphila species has the highest level of increased abundance. So this is the reverse of those with certain metabolic disorders. And then what else is interesting to see is Bifidobacterium and Lactobacillus having an increased abundance in those with Parkinson's disease. And this is interesting because these 2 strains are generally considered beneficial bacteria. They're found in many probiotic supplements and fermented foods. And as you'll see later in the seminar, these types of genera are even used in probiotic treatments for those with Parkinson's disease. But we do know that there are many confounding variables that impact the gut microbiome. So this could all be affecting a lot of the research. This image here outlines some of them. I'll briefly describe how each one impacts the gut microbiome. So we know that pharmaceuticals such as antibiotics can negatively impact gut diversity. We know that geography plays a role. So whether you live in an urban or rural environment or in different regions of the world, you have a different gut microbiome composition. Your gut microbiome changes in your different life cycle stages. So from an infant to when you're an elderly person. We know that the birthing process also affects the gut microbiome. Babies born via C-section don't receive the initial inoculation from a standard vaginal birth that those babies do. And then next we see that the infant feeding method also plays a role, as human breast milk has important prebiotics like galacto-oligosaccharides, which feed on the newborn's growing flora and fauna. Then we know that stress plays a role as well. On the positive side, exercise can impact the gut microbiome positively, whereas metabolic and psychological stress can negatively impact diversity. And finally, as we'll discuss today, diet plays a key role as well. So the consumption of probiotic or prebiotic foods can positively impact the gut microbiome, whereas processed foods or sugars have been shown to negatively impact gut diversity. Okay, next I'll define the microbiota-gut-brain axis. This is a bidirectional pathway that connects the enteric nervous system or the gut to the central nervous system. Some things that are at play here include the hypothalamic pituitary adrenal axis or the HPA axis, as well as the autonomic nervous system. This is believed why stress plays an important role in affecting the gut microbiome, as well as the vagus nerve. You see that the vagus nerve is sort of the superhighway that connects the gut to the brain, so it is able to send information between the two areas. And we know now that the gut microbiome affects the brain and CNS functioning through the microbiota-gut-brain axis. So how are these two connected, Parkinson's disease and the microbiota-gut-brain axis? Well, there is something known as alpha-synuclein. This is a protein that aggregates in the brain of those with Parkinson's disease. So alpha-synuclein aggregations are known as Lewy bodies that we see in the different brain regions of those with Parkinson's. A hypothesis states that alpha-synuclein aggregation begins in the enteric nervous system or the gut, then travels to the central nervous system via the dorsal motor nucleus of the vagus nerve. So as I mentioned before, that information from the enteric nervous system travels through the vagus nerve and eventually reaches the brain. And then once in the brain, we know that alpha-synuclein has demonstrated to have prion-like properties, and it spreads and propagates to other areas of the brain. So to study this, a non-human primate study was done where researchers injected Lewy body fractions or alpha-synuclein aggregations directly into the enteric nervous system. And they noticed that these aggregations traveled to the brain and propagated and affected various areas of the brain. However, they also noticed that when they injected these same Lewy body fractions into striatal regions of the brain, it propagated down to the enteric nervous system. So this study didn't prove the hypothesis, but it did show that it's a bidirectional route of propagation, and that there is some potential that it could begin in the enteric nervous system, but it doesn't necessarily have to. Next, it's important to understand that the gut microbiome is still very important in Parkinson's disease. So an animal model showed this from Sun et al. In 2018. So in this study, mice were given a drug known as MPTP. This is a drug that is known as the animal model for Parkinson's because the drug mimics the exact same effects of Parkinson's disease. So it creates those same hallmark biomarkers such as Lewy body formations, as well as the same motor and non-motor symptoms. So the study looked at mice that were the Parkinson's disease model, and then mice given a fecal microbiota transplant from other Parkinson's disease mice. And both exhibited microbial dysbiosis and Parkinson-like symptoms. So the latter group here showed that directly affecting the microbiota through the fecal transplant from Parkinson's disease mice also created the same dysbiosis and Parkinson-like symptoms to that of the mice given the MPTP drug. Then for treatment, mice that had the MPTP drug were given healthy fecal microbiota transplants from mice that didn't have Parkinson's disease. And upon receiving these fecal transplants, they had improved motor impairments, increased levels of dopamine and serotonin, and reduced expressions of pro-inflammatory signaling pathways. This demonstrated that targeting the gut microbiome can help manage the symptoms of Parkinson's disease, and gives credence to further studies using potential functional foods like probiotics and prebiotics that can target the gut and help deal with the symptoms of Parkinson's disease. So here are the results from that study I just mentioned. So on the left, these are showing how after receiving the unhealthy fecal transplant from Parkinson's disease mice, that they did a something called a pull test. And this test measures the level of bradykinesia, which is, if you remember, a motor symptom of Parkinson's disease. It's also just slow movement. So compared to the controls, the experimental groups had much slower descent times. So they had worsened bradykinesia. They also had less muscle strength and balance that was seen in the traction test. So the experimental groups had weaker muscle strength and balance than the healthy controls. Then with different neurotransmitters like dopamine and serotonin, the experimental group also had lower levels of these neurotransmitters, as well as some of their metabolites like DOPAC, HVA, compared to the healthy controls. So as I mentioned, negatively impacting the gut microbiome directly had effects that we see similar to Parkinson's disease. Then after receiving treatment, so mice here with the healthy fecal microbiota transplant were tested again. On the pull test, they showed improved descent times and improved score on the traction test. So it helped improve the motor symptoms, both the bradykinesia and the slow movement and muscle strength and balance. Then with the levels of neurotransmitters, mice that received the healthy fecal microbiota transplant had slightly increased levels of dopamine in its metabolites and increased levels of serotonin in one of its metabolites. We also saw that after receiving the fecal microbiota transplant to directly target the gut microbiome, there was a restoration of dopaminergic neurons, as well as levels of tyrosine hydroxylase, which is an important enzyme in the synthesis of dopamine. And finally, we saw how the treatment group that targeted the gut microbiome had reduced expressions of pro-inflammatory signaling pathways. So both in the colon and striatal regions of the brain, you see how mice given the healthy fecal transplant had results similar to that of the normal control, whereas mice that just were the Parkinson's disease model had much higher levels of pro-inflammatory signaling pathways. Again, both in the colon and the striatal regions of the brain. So next we'll discuss what are some potential functional food approaches to targeting the gut microbiome and thus Parkinson's disease. So we'll discuss probiotics and prebiotics. So first, probiotics, according to the International Scientific Association on Probiotics and Prebiotics, defines probiotics as live microorganisms that, when administered in adequate amounts, confer a health benefit on the host. Probiotics are often found in supplements, as well as fermented foods and beverages, such as kimchi, sauerkraut, or kombucha. And numerous studies have shown the health benefits that probiotics offer in treating many different gastrointestinal disorders. This is important because about 80% of those with Parkinson's disease suffer from these gastrointestinal disorders. So there are three effects I'll discuss that probiotics, how they positively impact health in humans. We know that probiotics can decrease epithelial permeability to different pathogens and strengthen the gut barrier. So the image here shows these three different effects. The first being that it improves gut barrier directly. The second is that it has effects on mucosal immunity. Specifically, probiotics can increase levels of immunoglobulin A, and this also contributes to gut homeostasis. And finally, we know that probiotics directly affect other bacteria. Probiotics change the gut microbiome composition by competing for binding sites with other sometimes harmful bacteria. This helps prevent the spread of pathogens and protects the gut barrier. So next I'll discuss some human clinical trials that were done with probiotics. So this 2019 human clinical trial tested the effects of probiotics on some motor symptoms of Parkinson's disease. The table here to your right shows some of those results, and the highlighted ones I'll discuss. So After receiving the treatment compared to the placebo group, the probiotic group had significantly improved scores on the Movement Disorder Society Unified Parkinson's Disease Rating Scale. This is a scale that measures the severity of motor symptoms in Parkinson's disease. So you can see that the probiotic group had significantly better results than the placebo group. Also, there was an increase in glutathione, which is an important antioxidant. The probiotic group also showed lowered high sensitivity C-reactive protein levels and lowered malondialdehyde levels, which is an important biomarker of oxidative stress. At the top, I shared these were the strains that were used in this particular study, and you can see how Lactobacillus and Bifidobacterium species were used. And if you remember, it's interesting that these are shown to be an increased abundance with Parkinson's disease. However, the supplementation of them helps treat some of the symptoms. Next, another human clinical trial in February of 2021 showed the effect of probiotics on a particular non-motor symptom of Parkinson's disease, which was constipation. Constipation is one of the most common non-motor gastrointestinal disorders in the non-motor symptom category of Parkinson's. So after receiving the treatment, the probiotic group had an increased average number of spontaneous bowel movements per week. It improved their average stool consistency as well as the overall quality of life related to the constipation. 2 other human studies showed similar results with the fermented milk. And again, you can see the strains that were used in this particular study. Again, Lactobacillus and Bifidobacterium strains were used, so they're very common. Next, we'll discuss prebiotics. These are non-digestible food products that benefit the host health by promoting the growth and activity of certain types of beneficial bacteria, such as the Bifidobacterium and Lactobacillus. They're found in dietary fibers. Some of these bioactive compounds are polysaccharides, oligosaccharides, galacto-oligosaccharides, which are found in human breast milk, inulin and fructans. In vitro and in vivo studies have shown that prebiotic administration increases the production of short-chain fatty acids. These are generally low in Parkinson's disease patients. And specifically, butyrate helps to prevent the pathogenesis of Parkinson's disease and restore dopaminergic neuronal loss. It also helps increase the intestinal epithelial barrier. And we'll discuss an animal model that was done using polymanuranic acid, which is a type of prebiotic that comes from brown seaweed alginate. So in this study, mice that were given the MPTP drug, which if you remember, this is the drug that makes the Parkinson's disease model for mice. So mice were given the polymanuranic acid prebiotic, and via the Microbiota-Gut-Brain axis, there were a few different effects. It improved motor functions and reduced the motor symptoms. There was some recovery of dopaminergic neuronal loss, as well as increasing the amount of neurotransmitters in striatal regions of the brain. So dopamine and serotonin were increased. After the prebiotic administration, there were changes in the gut compositions, as well as an inhibition of inflammation in the colon and striatal regions of the brain. And it improved the integrity of the intestinal barrier and the blood-brain barrier. So you see that these results from the prebiotic administration was very similar to the previous mouse study that showed targeting the gut through the fecal microbiota transplants improved in the same way. So in conclusion, we learned that the microbiota-gut-brain axis is a bidirectional pathway that connects the enteric nervous system or the gut to the central nervous system. We saw that evidence is emerging of its connection to Parkinson's disease, mainly through this pathway between the microbiota-gut-brain axis and Parkinson's disease. We see that there are composition differences and alterations of the gut microbiome. We saw that alpha-synuclein aggregations can begin in the enteric nervous system, then travel to the central nervous system and form the Lewy body distribution that occurs in the brain of Parkinson's disease patients. However, we learned in that non-human primate study that it's a bidirectional pathway. So alpha-synuclein aggregations that begin in the brain can also travel to the gut. So we don't know where the aggregations are specifically starting. We learned that the use of probiotics and prebiotics are effective therapies for Parkinson's disease and its symptoms, both the motor and non-motor symptoms. Currently, there's a substantial amount of research on the microbiome, but there's much more potential. Future research should continue to investigate the connection of these systems, the microbiota-gut-brain axis, the gut microbiome, and specifically how probiotics, prebiotics, and other potential functional foods or dietary styles can help with Parkinson's disease. So fermented foods and beverages, omega-3 fatty acids, a Mediterranean style diet, or symbiotics. I think symbiotics are very important in future research, as we saw the results from probiotic administration and prebiotic administration had similar results in affecting the motor and non-motor symptoms of Parkinson's disease. So the two of these combined could have synergistic effects in helping patients with Parkinson's disease. And then in accordance with the Functional Food Center's vision of developing functional food products and following the 15 steps outlined, it's very important that epidemiological studies are followed up and more human clinical trials are done to study the effects of symbiotics on Parkinson's disease. So if there are any questions, these are also some of the references used for this presentation.
Okay, any questions? Yeah, I would like to do on a comment, and you can see Stella if someone have a question. My comment is that, yeah, actually coming from our definition of functional food center, saying that bioactive compounds or functional foods can manage disease or its symptom. In this case, so we see that development that we did later on, not in first as we come to that definition, that in this case, probiotics are not able to manage whole disease, but it's very interesting that they were able to manage two at least symptoms. So as I understand myself, so lactobacillus and bifidobacterium together we are able to manage constipation and as well as motor function, but still remaining. So we can say that it is possible only using this two bacterium managing whole disease, but certainly managing for two symptoms. So that's very good improvement. That might be Hunter have something to say.
Just to definitely reiterate what you mentioned, Dr. Martirosyan, that this is early research showing that there's more potential. And as we saw that there are a lot of non-motor symptoms that affect Parkinson's disease, especially the gastrointestinal disorders. And we already see how through a lot of different research, there are ways that prebiotics and probiotics can help manage the gastrointestinal disorders. So I think it's definitely an area for researchers to investigate. As we know, Parkinson's disease is also each year more and more cases because of an ever aging population, and with like the baby boomer generation reaching those different age groups like 60 and 70, that's a prime time where Parkinson's disease might develop. So I think this is a timely topic that needs to be researched for the population that we currently have.
Yeah, very good. Yeah, and certainly since we have here, we can have simply a regular common product, right, like yogurt, kefir, which have lots of lactobacillus and bifidobacterium as a healthy bacterium. So it is not difficult actually organize some epidemiological study in this case. Even people can not be clinical. Of course, we saying usually it's better for functional food investigation. It's better having a clinical studies, but certainly some cohort or other kind of epidemiological studies with uncontrolled environment. So certainly could be very helpful. So we hope that in future, going to be more studies in this area. And I'm glad, you pick up just very latest studies from 2021 also. So look like really there is some effect. Okay. So Stella, if you can continue, if there is no any other questions.
All right. Yeah, so the last part of the seminar, we're going to go over review questions that are based on this seminar topic. So if you're in a standardized program, these are questions that you'll need to know for passing the program and getting your certification. But even if you're not in the program, I still encourage you all to try out these questions. So we'll have around 5 minutes for this. And then after 5 minutes, we'll come back and go over the answers. But actually, before we do that, I do see a question in the chat now. So is there a relationship between prolonged antibiotic consumption and Parkinson's?
Yeah, so that's definitely a good question. I didn't look up any particular, because this seminar was focusing mostly on the potential functional foods. I did mention that those different confounding variables, such as antibiotic use, I would say that it's worth looking into. I wouldn't be surprised if there's a relationship. I know nowadays doctors are trying to prescribe probiotics when given antibiotics, especially for prolonged time, knowing the effect that it has on gut bacteria. But I would definitely think that's an important part of research to do when helping, research about Parkinson's, is also looking for things like that that could be affecting, for sure, prolonged antibiotic use.
All right, so there's no further questions. I'll launch the poll now and we'll come back in 5 minutes. So at 10:08. All right, so it is 10:08 and I will end the poll now and share the results.
So question 1 was, what is the greatest, sorry. Move this. Okay, so question 1 is, what is the greatest risk factor in developing Parkinson's disease? The answer is C, aging. I mentioned that earlier, that aging is currently the greatest risk factor. These other 3 definitely play a role, but as of now, aging is the greatest risk factor. Question 2 is, approximately what % of people with Parkinson's disease have gastrointestinal disorders? And the answer is 80%. The next question, the bacterium Akkermansia muciniphila is shown to be decreased in people with metabolic disorders. However, it is most commonly seen in an increased abundance in people with Parkinson's disease. So B is the answer there. Question 4, the answer is C. So a hypothesis on the pathogenesis of Parkinson's disease explains that the protein alpha-synuclein aggregates in the enteric nervous system and travels to the central nervous system via the vagus nerve. Then the question 5, a non-human primate study helped prove the hypothesis mentioned in question 4. The answer is false, although I understand people might think it's true, but this didn't prove the hypothesis because, as we saw in that study, while it did travel from the enteric nervous system to the central nervous system, which is what the hypothesis states, the reverse was also true, that when injected into the central nervous system, it traveled to the gut. So it's hard to tell what is the causative factor here, or where the aggregations are really beginning, whether it's in the gut or the brain, or it could be both depending on each case. But yeah, that hypothesis wasn't definitely proven with that non-human primate study, because we saw that microbiota-gut-brain axis is bidirectional. Question 6 is the mouse study from Sun et al. In 2018 showed how healthy fecal microbiota transplants increased which two neurotransmitters in mice given the MPTP drug, the Parkinson's disease model of mice. The answer is C, dopamine and serotonin. And this was actually seen in the other studies too. The prebiotic study also showed how the prebiotic administration increased dopamine and serotonin as well. Question 7, the answer was D. In animal models of Parkinson's disease, the pull test measures bradykinesia, which is slow movement, while the traction test measures muscle strength and equilibrium. Question 8 was, according to the presentation or text, what are 3 effects probiotics are known to have to improve gut health? The answer was A, so direct effects on the intestinal epithelium, effects on mucosal immunity, and effects on other bacteria. Question 9 is the clinical trial study in 2019 found that probiotics had significant effects on multiple markers of Parkinson's disease. 2 of the results were, and the answer is B, improvement on the Movement Disorders Society Unified Parkinson's Disease Rating Scale. So it improved the severity of motor symptoms. And it increased levels of glutathione, which is an antioxidant. And finally, the last question 10, a clinical trial in 2021 measured the effects of probiotics and which symptom of Parkinson's disease. The answer was D, constipation, which is the most common type of gastrointestinal disorder in people with Parkinson's disease. Okay, so those are all the questions from that seminar. And I thank everyone for attending and for participating in those poll questions. And I hope everyone learned something new and hope everyone has a great rest of their day as well.
So next week is going to be our last seminar of this series. So, thank you everyone for making it this far with us. And we do hope to see you at our last seminar. It's going to be a presentation about functional food regulation systems done by Dr. Martirosyan. So really encourage you guys to come out.